In this lesson, we're looking at transposition. So this is probably a skill you've done before, but it's good to review. So the idea with this whole lesson is that we're trying to solve equations where there's more than one variable, or there's parameters where the variable has not yet been defined. So a really simple one that will help you understand what we're doing here. A few lessons ago, we looked at the quadratic rule. So that rule being x is equal to negative b plus or minus the square root of the discriminant on 2a. So we've got parameters a and b there. We've got x, which is a variable we're trying to solve for, and we've got a third piece of information, which is discriminant. So if I wanted to isolate the discriminant to change the function and make it in terms of the discriminant, then we're going to follow an algebraic process where we isolate that particular variable. All right, so we just go through our normal process. We're going to use everything we know from solving equations, and we're just going to use it in a very similar way. So if I was looking at trying to isolate the discriminant, then the process is the same as always. We're trying to move everything away from the discriminant by performing the same operations on both sides of the equation. So looking at this first step, first thing we need to do is get rid of this 2a. In order to do that, we can multiply by 2a on both sides. So multiply by 2a, and we've got 2ax is negative b plus or minus the square root of the discriminant. The second step would be we need to get rid of this negative b. So to get rid of negative b, we would add b to both sides, and we end up with 2ax plus b is equal to plus or minus square root. And the last thing we need to do to isolate that discriminant is we want to square both sides. So if we square, then we get 2ax plus b all squared, and that will be equal to the discriminant. If you're not sure what happened to the plus or minus when you square, obviously the outcome will always be positive. All right, so what this is saying is that there's another way to determine the discriminant. All right, I'm hoping that makes sense. Now, I will kind of point out that when we're rearranging and isolating, the idea is that we move or we deal with the element that's farthest away from the variable we're trying to isolate. So in each case, it was the 2a was farthest away, then it was the negative b, and then it was that square root. You probably should be thinking that we're reversing operations, so we're using the opposite of BOMDAS. So in every step, we think SAD mob. That means that first of all, we deal with any add or subtract. We deal with any multiply or divide. And then we deal with any powers. And brackets is a weird one because usually we just expand them out to deal with them at the start. So in every step, it was about making that decision. Now, the first one is a little bit of a tricky one. The idea is that when you've got a fraction, you have to think about them as in brackets. So the idea is that everything that's on the top there is actually in brackets. So because brackets is last, we can't do that. And the only thing that we can do is realize that this on 2a means we're dividing by 2a. And so the first thing we'll do is reverse that. The second step was pretty easy to see. We've got to subtract b. We can get rid of that by adding. And the third step, we only have that square root. So that square root falls under powers, so we can square to undo that. That's basically the idea. Every single step, we think SAD mob, which is the best thing to do. And then it just becomes a fluency thing. The more you practice, the more you get that pattern and that order right in your head. All right. So fairly easy examples. We're looking to solve each of the following for x. So we're using that transposition skill. The first one, we have px take q is equal to r. So if we're thinking SAD mob all the time, every single step we think SAD mob, I can see if we're trying to isolate x, the thing that we have to deal with first is the addition or subtraction. So if we want to get rid of that negative q, we have to add q to both sides. So we add q to this side and we get px. Add q to the other side, we get r plus q. Now we've got x is multiplied by p. To get rid of multiply, we want to divide. And so that means we divide both sides by p and we get x, and we get r plus q divided by p. So the easiest way to represent that is as a fraction. All right, when we look at the second one, we've got a little bit of a dilemma. We've got ax plus b and cx plus d. It's not quite so easy because we've got x is on both sides of the equation. So the first thought needs to be we need to get those x's together, and we need to get everything on the other side, or everything else on the other side. So my first thought would be that I could subtract cx from both sides. So if I subtract cx, then I've got ax take cx, we still have that plus b, is equal to d. And then I could subtract b from both sides, and now I've got ax take cx is equal to d take b. Now this one pops up a lot in Method Specialist. It's one of those scenarios where you have multiple x's and you want to isolate. The trick here is to realize that x is actually a common factor. So if we take x as a common factor, we're left with a take c is equal to d take b. And the last one is that we can divide both sides by that whole bracket, a take c. So it becomes d take b over a take c. So if I write down those steps, we went subtract cx, because that was logical, and then subtract b, and then it was factorize using x as a common factor, divide by the whole bracket, a take c. So hopefully that makes sense. Now the last one's a bit of a fun one, but again, if we look at it and we realize what we're trying to isolate, then life does get a little bit easier. Now with this whole fraction thing, I always find the easiest thing to do is to multiply by a value that will get rid of all the fractions at the same time. So my thought would be I could multiply by 2x. So I know we're trying to isolate 2x, but we definitely don't want 2x on the denominator. So if we multiply by 2x, then we've got 2a, we've got b, and we've got c multiplied by 2x. Now once we get to this stage, it's just a matter of rearranging, isolating, right? So if I subtract b, I get 2a take away b is 2xc. And now if I want to isolate just for x, I could divide by both 2 and c at the same time. And so that means I've got 2a take b on 2c. So those steps were, again, it's logical here to subtract b because that's add, subtract. And then we want to divide by the whole 2c. Okay, so that might take a little bit of practice. It's definitely good for building your algebraic skills. And it's nice to be able to solve things without having to sub values into them before. A little bit more complex, this equation, we've got f is equal to mu I squared over 2 pi r. And the first one is asking us, A, isolate for the variable I. So we've got f is equal to mu I squared on 2 pi r. So the first thought should be we can deal with that. So I can multiply by the whole 2 pi r. And that means now I've got 2 pi r f is mu I squared. Now I want to get rid of mu, so I can divide by mu. And that gives me 2 pi r f on mu is equal to I squared. And the last one is we want to square root in order to get rid of that square. So we end up with I is equal to plus or minus. Remember that plus or minus is important. 2 pi r f on mu. Alright, so happy days. Part B, when we're just isolating for r, the first thing we want to do is get r off the bottom. So that first step is pretty similar, I would say. Going to multiply by 2 pi r. So 2 pi r f is equal to mu I squared. And because the 2, the pi, and the f is all multiplied by r, the easy thing here is to divide by that. So divide by 2 n pi and f. And that leaves us with r is equal to mu I squared on 2 pi f. Okay, so hopefully that makes sense. The same skill, transposition. The idea is we're always thinking SAD mob. We're trying to work out what operation we need to perform next. And there's a skill that's really, really going to be important for you through 10, 11, 12. All right, so the last two skills, this one's pretty easy. I thought I'd throw this in because it's important to note that there is really two ways we can go about the substitution-based questions. We can rearrange first and then sub in, or we can sub in and rearrange. If you're doing multiple calculations, it's always best to rearrange first and then sub in. If you're only doing it once, then it doesn't really matter. So this example here, we want to isolate that value and then evaluate for A. So in other words, we want to isolate A and then evaluate for it. So we've got V is equal to U plus AT. It's just a U, not a mu. The first step would be we can get rid of the addition first, so we can subtract U. So now we've got V take U. And if we want to isolate A, then we can divide by T. So we end up with A is equal to V take U on T. First approach, now we can sub in V equals 25, U equals 0, and T equals 6. So it's a nice simple calculation. We've got 25, take 0 on 6. That gives us 4 and 1 6, which will be 4.16 reoccurring. The alternative is we could have rearranged from the start. We could have put straight in and gone 25 is equal to 0 plus 6t. So 25 is equal to 6t, and therefore t is 25 on 6. We can see it's the same outcome, and we end up with that 4.16 reoccurring. So I don't really mind which way you go, but this transposition skill allows us to go, let's say we had to do this substitution 100 times. We don't want to rearrange it 100 times. So therefore, it's good to work out the rule first, and then we can use Excel or something like that to do the calculations for us. Okay, last example. So in our last example, we're solving simultaneously. So this is the same skill that we know we can use substitution, elimination, and we'll learn more simultaneous solve skills through specialist in year 11 and 12. But right now, we're basically trying to solve with X and Y, but in terms of A, B, C, etc. Okay, so if we take our normal approach, we've got Y is equal to AX plus C, and we've got Y is equal to BX plus D. We can say this is this is equation 1, this is equation 2, and really because they're both in terms of Y, we can just sub 1 into 2 or 2 into 1 and it works the same, right? So let's say sub 1 into 2. So here we have AX plus C is equal to BX plus D. Now this is very similar to something we solved just earlier. So AX plus B is equal to CX plus D. Well, not exactly the same, but close. So let's subtract BX and subtract C, and we've got AX take BX is equal to D take C. Factorize X out. A take B is D take C, and X is equal to D take C on A take B. So now we've solved for X. Don't be worried about the fact that X is in terms of D, C, A, and B. That's fine. That's what we're looking for. We're looking for an isolation of X in terms of the parameters A, B, C, and D. Now we can solve for Y by subbing into either 1 or 2, or both, if you prefer. So let's say just sub into 1. Now we've got Y is equal to A multiplied by X, which is D take C on A take B, plus C. And we can expand that out if we want. We can simplify it. We can make it pretty. It'll be the same if we do it either way. So, for example, if I went, well, if I multiply A through here, it becomes AD take AC on A take B plus C. but that plus c isn't good enough because it's not on that fraction, a take b. So if I multiply that by a take b on top and bottom, then we end up with AD take AC plus AC take BC all over A take B, and our A take C's in the middle cancel out. We end up with AD take BC on A take B. So we could do that. I'm not too worried at this stage if we get to this form and we leave it like that. I do recommend you practice this skill, that simplification. All right, so now if we look at the second one, so we've got B, solving for x and y again. So here we've got ax take y is equal to c, and x plus by is equal to d. Now my thoughts would be that I can isolate x easiest. So I can say that x is equal to d take by because I can just subtract by from both sides. So now we've got 1, and we've got 2, and we can sub 2 into 1. So that gives me a d take by take y is equal to c, and we can go about our business trying to isolate y. So we've got ad take aby take y is equal to c. I want to isolate y because I'm going to add aby and y, and I'm going to subtract c, but I'll add the y's first. So now I've got AD is equal to C plus ABY plus Y. And when I subtract C, I've got AD take C is ABY plus Y. The idea behind getting the y's on their own, now I can take y out as a common factor. So there's that skill again. And we can divide by AB plus 1, and we end up with y is equal to AD take C on AB plus 1. So that's pretty complicated. It's not easy algebra. There's lots of steps. There's thoughts. You maybe have a better way to do it. You may have isolated y, for example. The last step, obviously, is we want to sub that back in. So we want to sub into. Now it makes sense to sub into the one where x is isolated. So we want to sub into 2. So that means we've got x is equal to d take away b multiplied by y, and y is AD take C on AB plus 1. So let's go through that process of simplifying again. Let's get it all on a common denominator. So that means that this D needs to be multiplied by AB plus 1, and it needs to be over that. So now that they're all on the same thing, we can expand this into the bracket. So we've got negative BAD, and negative B times negative C is plus BC. And now it's just a matter of expand out, simplifying. So we've got DAB plus D take bad plus BC over AB plus 1. And that's our solution for Y. Okay, so hopefully that all makes sense. Not easy. It's a skill to work on. Transposition is fun. You'll use it when you start doing more high-level algebraic manipulation and proofs and all that type of thing. We don't have values to sub in, so we have to be able to do it without substitution of values. All right, and some nice fun examples at the end. So there is 2 exercises there. I really want everybody to do this one first. So you can see it's got a bit of all the skills, solve for x, for simultaneous equations. So there's a bit of everything in there, and I think that'll keep you busy. If you somehow finish that all, then there's a bunch of extra transposition questions with some application stuff at the end. Okay, so hopefully that's all good, and thank you for listening.